Hi there everyone, I am Mayur Gohil. In this video lecture of recurrence relation, I shall be solving one special problem in which I will be dealing with repeated case of the roots of the recurrence relation, of the characteristic equation rather, and we will be using method of characteristic roots. So let us see what is special about this problem and how to solve this problem. Okay, so this is the question that we have been given. This is our recurrence relation an minus 8an minus 1 plus 21an minus 2 minus 18an minus 3 equals to 0, and we have, for the first time, we have three initial conditions over here, that is a0 is 0, a1 is 2 and a3 is equals to 13. Okay, so let us jump into solving this question. First of all, the method remains almost same, there is no difference, only slight changes are there. So consider the recurrence relation that has been given to us. Step 1 is let an equal to alpha to the power n. So because of this step, our recurrence relation gets converted to alpha to the power n minus 8 times alpha to the power n minus 1 plus 21 into alpha to the power n minus 2 minus 18 times alpha to the power n minus 3 equals to 0. Okay, now if you observe over here, the smallest power in this expression is nothing but alpha to the power n minus 3. So you divide it by that. So step 2 will be alpha to the power n minus 3, you divide it on the both the sides. So you obtain the following equation, that is alpha cube minus 8 alpha square plus 21 alpha minus 18 equals to 0. Now this is a cubic equation. If you know how to solve cubic equation using Cardano method, it is well and good. Otherwise you can use synthetic division method, which is taught to you in high school or school level, or you can use any other method which is available to you. If you are allowed to use calculators during your examination, then you can plug in the values of the constants and get the answer for it. So now over here I obtain the following factors: alpha minus 2 times alpha minus 3 the whole square equals to 0, and the roots that I obtain is alpha equal to 2, 3 and 3. So that is what I wanted to discuss over here. This is what is important. Okay, now observe the nature of the roots, that is the root alpha 1 is just repeated one time, and the root alpha 2, which is 3, it is repeated 2 times. So how to write a solution for a general solution when this kind of case occurs? So now recall the statement that I had made in the previous video lecture. If a root alpha star is repeated m times, then its general solution is given in this manner. Okay, but I had also promised you one line over there that I shall explain in this video lecture, that is a linear combination of such solution is also a solution to the recurrence relation. Now that is the line that is going to be coming into the picture. First of all, let me write the general solution over here. It appears in this manner, that is an is equals to a1 alpha 1 to the power n plus bracket a2 plus a3 n times alpha 2 to the power n. Does this come? Let us see. First of all, observe here, alpha 1 equal to 2 is a root which is repeated only one time. So if you try to analogously write this using this statement that we had made last time regarding repeated roots, what do you observe here is that alpha 1 repeated just one time, that means an is equals to a1 alpha 1 to the power n. That is what you get, because you just have to write this expression only till that many terms, that the number of times it is repeated. So alpha 2 is just repeated one time. So if you observe, there is how many constants are there? There are that many constants as many times the root is repeated. So it is just repeated only one time, so there will be only one constant, so that will be a1. So it is repeated one time, right? So you write a1 alpha 1 to the power n. Okay, now observe over here, the root alpha 2 equal to 3, it is repeated two times. And now as per this notion that we see this statement over here, you will have to write two constants. Okay, the number of times it is repeated, it is 2, so there will be two constants, and you will have to go how many powers of n? You will have to go one power less the number of times it is repeated. So you will have to go up to a2 to the power a2 times n to the power 1 into alpha star to the power n. Now observe here very carefully, I have written a2 and a3. So you don't get confused with it. Only thing important is that because a1 I have already utilized, I am now writing it as a2. Okay. Also, now you see that for a2 equal to 3, it is repeated two times. As I said, we have two constants and we will be writing up to the power of n. Okay, n to the power 1. So, and now if you observe this entire expression, alpha star to the power n can be taken common. So that is what I have taken common. Okay, so thus, and now one more line that I had said, that any linear combination of such solution is also a solution to the recurrence relation. That is why I have added both the solution. a1 alpha 1 to the power n is a solution for alpha 1 equal to 2 and a2 equal to 3. You have this as the solution. Alpha 2 equal to 3, we have this as a solution. Okay, thus I have added them because it's a linear combination. So thus what do we have? Our solution over here, general solution, when you put alpha 1 and alpha 2, you obtain this as our general solution, that is a1 times 2 to the power n plus bracket of a2 plus a3 n times 3 to the power n. Okay, so this is what is our general solution and you can jot it down. Okay, now we will have to find a1, a2 and a3. These are three constants which will be found using the initial condition and this general solution. So let us go for finding that. Okay, now a0 as our first initial condition is given to us equal to 0. So over there the suffix is n. Okay, an is equal to that is what we have in our recurrence relation. So the suffix n over here, if you compare, it is n equal to 0, and thus from the general solution you will obtain a0 equal to a1 plus a2. Now a0 is 0, so you obtain an equation a1 plus a2 equals to 0. Now you go for the second initial condition, that is a1 is equals to 2, thus n is equal to 1. Now you plug up these values in the general solution that we had obtained. You obtain the equation a1 plus 3a2 plus 3a3 equals to 2. Now you go for the third initial condition, a2 equals to 13. Now if you see the suffix over here, it is 2. Thus n is equals to 2, and you put this value of n equal to 2 and a2 equal to 13 in the general solution star. You obtain the equation 4a1 plus 9a2 plus 18a3 equals to 13. Now in front of you I have bolded these three equations. So what you see is that you have a system of linear equations in front of you, which can be converted into a matrix in this manner. Okay, now recall the theory video lecture of method of characteristic roots. I had spoken that you will need to use Gaussian elimination method. If there are two equations and two unknowns, you will be using simultaneous equation solving method. But if there are three equations and three unknowns, or more equations you have and that many unknowns, you will have to use Gaussian elimination method. Okay, but if you are allowed to use calculator, and if your calculator permits, you can plug up these values into the calculator and you will get a1, a2, a3 as 1, -1 and 1. But if you do not have any calculator to use, then you will have to go by Gaussian elimination method and you will have to use all these row transformation on this coefficient matrix. Okay, do them one by one. Okay, and you will finally land up a1, a2, a3 equal to 1, -1 and 1. Okay, so now after solving this for a1, a2 and a3, you substitute these values in the general solution that we had found, and then you will get your explicit solution for the recurrence relation, which is an equals to 2 to the power n plus minus of 1 plus n times 3 to the power n. Okay, now that same thing can be rewritten in this manner, which looks little nice. That is, an is equals to 2 to the power n plus n minus 1 to the power n minus 1 times 3 to the power n. Okay, now just go through the entire problem. The speciality of this problem was that for the first time you have got 3 equations, okay, in this problem, and the main case was that you had one root which is not repeated and other 2 roots are repeated. So in that case the general solution is written in slightly different manner, and you have 3 equations coming into the picture for which you are sometimes forced to use Gaussian elimination method if you are not allowed to use calculator. Okay, now go through the entire problem once more, and for you I leave a practice problem. Okay, over here also there are 3 initial conditions, so you will get 3 equations and then you can solve them using Gaussian elimination method or calculator, either way. And please revert to me back if you have any difficulties related to this topic. I shall reply to you as soon as possible. If you like the video lecture, please hit like button and share it with your friends. Till then, keep solving good amount of mathematics. I shall soon see you with the other topics of the recurrence relation in the other video lecture. Thank you.